Good afternoon, ladies and gentlemen. I'd like to welcome you all to the Intrepid Sea, Air, and Space Museum to our virtual programming. Thank you for joining our Intrepid Museum's live virtual programming. My name is Franz. I'm a museum educator at the Intrepid Sea, Air, and Space Museum, where our mission is to honor our heroes, educate the public, and to inspire our youth. Today, you guys are going to be joining us for our Intrepid adventure, which we call Lunar Landers. I look forward to hearing your questions throughout the program, and I hope to address as many as I can. Now, the museum's live streams are free. And if you'd like to support us in delivering these new exciting programs, please click on the link that's in the description below. Okay, so today we are going to be talking about lunar landers. We're going to be talking about landing here on Earth, up at the moon, and beyond. All right. Now, in order to do this, we are going to look at some really cool images and videos to talk about the museum and its connection to outer space and why we talk about this in the first place. All right. So we are going to look here. And as we look at this picture, at this image, we see the Intrepid. If you didn't know what the Intrepid is, there it is right there. The Intrepid is a large aircraft carrier, right? Now, the Intrepid was made back in 1943, right? Served in 3 wars, World War II, Vietnam, and the Cold War. In 1974, it was retired and no longer used for military service. And in 1982, we became the Intrepid Sea, Air, and Space Museum, right? Now, the C part makes sense, right? So let's talk about why we have that name, right? The C part makes sense because the Intrepid is a seafaring vessel. It would have been in the Atlantic and Pacific Oceans during these particular times of conflict, right? It would have been in the water. And this kind of proves what this thing is, right? Because you guys can let me know in the chat what we call something like this, right? And the Intrepid had 4 of these things on the ship, right? And it pushed it through the water. As you can see here in this picture, the Intrepid sailing through the ocean, right? That's the sea part. The air part makes a little sense too when you look at the top part, right? Because you can see right there in the back part of the ship here, we have airplanes, right? The Intrepid is what we call an aircraft carrier. It not only carried aircraft, but it had the ability to launch and land these aircraft, just like an airport that's in the water, right? So it's pretty special because of that, right? And the Intrepid wouldn't have only launched propeller-powered planes. It would have launched jet-powered planes as well. So as you can see, jet planes taking off from an aircraft carrier here, right? So I see some answers there. So I see some people saying turbines, close guess, but the answer is we call those things propellers, just like the propellers that are on propeller-powered planes. These are large bronze propellers that actually turn to push the ship, right? But the Intrepid launched planes off of its flight deck, and that makes sense why we're an air museum. Planes like the Fury that you see here, jet-powered planes. But the space part is the part that doesn't really make a lot of sense when people come there. A lot of people think we're a space museum specifically because we have the very first space shuttle. Sorry, spoiler alert. We'll talk about that later. But we'll talk about why we're a space museum now. Now, this here, you guys can let me know if you know what this is in the chat. Also, by the way, throughout the entire program, if you have any questions, feel free to type them into the chat. And we're going to have some sections in the program where we're going to address those questions and answer some of the questions that you guys have at home. Now, what we're looking at is what we call a space capsule, right? This is the Mercury Aurora 7 capsule. And this is the man that would have been inside of that capsule. This gentleman's name is Mr. Scott Carpenter. Mr. Scott Carpenter would have went up into space inside of that capsule. By the way, this capsule is just a replica, a full-scale replica, meaning it is the same size, but it's not the actual thing. And this had Mr. Carpenter ride on the top of a rocket. And when these capsules come back down, right, this is how they come back, right? You have these large parachutes. These large parachutes are just to slow them down, and then they splash down in the Atlantic Ocean, right? You guys can write down in the chat why you think you would probably want to land in the ocean over landing on the land, right? But he would have landed in the ocean there, and he would have been rescued by a helicopter. Interesting story about Mr. Carpenter, though. Mr. Carpenter had a lot of jobs when he went up into outer space. He was doing a lot of different things. And one of these things caused him to keep hitting things and losing fuel. So he was losing fuel while he was up in outer space. He also noticed that some of his instruments weren't working, and the instruments that were to tell him where he was in relation to the Earth wasn't really giving him accurate information. So, and he also fired his thrusters 2 seconds too late upon reentry, just 2 seconds, and he ended up landing over 200 miles away from where he was supposed to land. Right. And if that wasn't bad enough, he got out of his capsule and was waiting in this little raft right next to his capsule without his radio. So when NASA was radioing for him, they didn't get any response. Luckily, a helicopter was hovering over, and they saw the spacecraft, and they saw Mr. Carpenter, and they eventually picked him up. And you can see him hanging off from the helicopter right there, right, which is pretty cool. Now, where's that helicopter going to land? Anybody want to take a guess? You can write it in the chat where this helicopter might end up landing. As you can see, it has the word Navy on it, right? It kind of looks like helicopters that we might have saw in this presentation already, right? It would have landed right on Intrepid's flight deck. So you can see Scott Carpenter right there on Intrepid's flight deck with some of Intrepid's officials, right? So we had a pretty successful mission, all things considered. Do you guys have any questions about the Mercury capsule, about that mission? Any questions at all? Feel free to ask those questions, all right? So as I said before, the Intrepid went out, picked up Mr. Scott Carpenter, but it wasn't the only astronaut and the only capsule and space mission that the Intrepid was involved with, right? So let's see if we have some questions before we move on to that next capsule. Let's see if we have some questions. So let's see. So someone says, the Mercury capsule looks very tiny. How tight was it to fit inside of it? Well, it was pretty tight. Initially, when they were sending up astronauts, they didn't really know what was going to happen to the astronauts. So they sent them up one at a time. And one of the things that they wanted to make sure was that there wasn't too much stuff inside of the capsule, because then that would add weight. So what they did was they made sure that it was pretty cramped inside, but enough room for the astronauts to do the jobs that they had to do. That's from Dave Hopkinson. So thank you so much for that question. Any other questions about the Mercury capsule? Now, I'm actually going to go back to check out the Mercury capsule so we can see it here. As I said before, only one astronaut fit inside of it. What is the Mercury capsule made out of? It's made out of a couple of composite things, right? Mostly, though, titanium has titanium in it, which makes it pretty strong. It also has an ablative heat shield on the bottom, which is a fancy name for something to protect it from heat when it's coming back into Earth's atmosphere. Great question. Someone asked, where did the capsule land? So this capsule in particular landed in the Atlantic Ocean, a little bit off the coast of Florida, where the ship went out to go pick it up. From Joseph Luna Pitch. Thank you so much for your question. All right. So let's move on just a little bit down the hangar deck. We would see the second capsule, or at least a replica of the second capsule we picked up, and it is here. Well, this is the actual thing here, the capsule, the Gemini capsule. And the Gemini missions came after the Mercury missions, right? Now, the Gemini missions were called Gemini after the constellation of the twins, right? And so they would have two astronauts inside of it. So the astronaut on the far left, far away from us, is Mr. John Young. And the astronaut closer to us here is Mr. Gus Grissom, right? They went up into space. They did 3 orbits around the Earth. They actually ate something they weren't supposed to eat in space. They ate a corned beef sandwich on rye bread, right? But their mission was a success. And they splashed down the Atlantic Ocean as well. And they were rescued by the Intrepid, picked up by the Intrepid, right? So you can see right there, the Intrepid kind of parked alongside of the capsule as it's waiting in the water to be picked up, right? You can even see it has a yellow flotation collar around it, right? By the way, you can ask any questions you guys want about the Gemini capsule, but I want to tell you guys a quick story about an earlier Mercury capsule, right? And why landing in water, you have to be very aware of where you're landing and what your capsule is doing in the water, right? So Gus Grissom was one of the Mercury 7, right? One of the first original astronauts to go up into space during the Mercury missions. And he was on Liberty Bell 7, right? One of the Mercury capsules to go up into space. He went up into space, did his mission, came back down and landed in the ocean. Something happened, though, to his capsule where his capsule door blew open too early and water started to fill into the capsule and his capsule started to sink. So he was in, a really, really hairy situation. Luckily, though, his ship came right when it was supposed to, and he got saved. His capsule, though, wasn't so lucky. It sank deeper than the depths of the Titanic, and it actually took over 20 years for them to actually find it. So, yeah. So that's what happened with Mr. Gus Grissom during his first mission. So this mission, he thought it would be funny to name his capsule the Unsinkable Molly Brown because he didn't want it to sink. And after that that hairy situation, what NASA started doing was they started fixing these, making sure that all these capsules had these flotation collars around it, so that way it would float while it was waiting to be picked up. So he was fine, though. He was perfectly fine. Any questions about the Gemini missions? Any questions about those missions? How many people were involved in designing and building it? Well, there's a lot. Thank you so much for that, Usher. There's a lot of people that were involved with doing this. This is the entire NASA administration was actually working on this and making sure that everything was going on well with this. This is the reason why there were so many successes. I don't have an exact number, but there were a lot of people working on the logistics of not only building the capsule, but making sure it was able to go up into outer space on the rocket and come back safely. How far into the Atlantic Ocean did the capsule land? So this one went pretty far, a little bit far off the coast of Florida, but then also, not this one, but the other one landed 200 miles away from where it was supposed to land. When these capsules come back, there's a pretty accurate area where they're supposed to land based off of math and how fast they're going and how high they are. And they can actually pinpoint really close to where you're supposed to land. As a matter of fact, one of the most accurate landings was of Gordon Cooper, one of the Mercury 7 astronauts. He landed a couple of feet away from where he was supposed to land, and he did that landing manually, just using his watch and the sun and the stars in the sky. And he figured out where he was supposed to land and was about a foot off, which is pretty cool. And maybe if there's one more question, maybe, no? That's okay. We'll come back. We'll come back to questions in a second. Now, after the Gemini missions, now it's time to start sending astronauts very far, right? We're going to send astronauts all the way to the moon. And in order to send astronauts to the moon to land, we have to do things in a very interesting way. Now, by the way, this is the capsule being pulled up out of the water. You can see that flotation collar right around it, right there. Oh, sorry. How could I forget? Before we go to Apollo, we're actually going to go past Apollo really quickly. We're going to still talk about landing here on Earth. Now, there's a picture here, and you guys can write in the chat what you think this is. I love this picture just because of the colors and just because of the silhouette image kind of in the middle of the picture. What do you guys think we're looking at? What are we looking at as we look at this image? Sorry, I see another question that I got to answer. Sorry. Someone asked, Jamie Jackson asked, how did they go to the bathroom in space? Well, now, initially, when they first went up into outer space, they were only going up for a short period of time. So they actually didn't have much in the way of bathrooms. What they did have were maximum absorbency garments, which are diapers, right? Just in case they had to use the bathroom. As time progressed, they eventually got these things that were pretty much plastic bags that they could use in outer space. And that built up to them actually getting a toilet, not like we use at home. It looked a lot like a porta potty, but it functions a little bit differently. And this is what they use on the International Space Station, right? Now, this image here is of the space shuttle, right? The space shuttle flying into orbit, actually. Right? Now, this is the space shuttle that we have at the Intrepid. And although some people get a little disappointed at this, it's still pretty cool that this is the first space shuttle. although it never went into outer space, right? It was a testing vehicle just to see if this bird had wings, if something so massive could glide through Earth's atmosphere and land on a runway just like an airplane. Now, look at the difference between the two, right? With the first capsule that we talked about, we're going to be landing in the ocean. The second capsule we talked about, we're going to be landing in the ocean. This is different. This is going to be landing on land specifically because they wanted to be able to reuse this, right? So they had to control its landing. And what better way to control its landing through air than something that looks a lot like a like an airplane, right? So they took a 747 jet, a modified 747 jet, and they strapped it to the back. They strapped the Enterprise on top of it, right? So you can see there the Enterprise right on top of this plane that says NASA. You see the Enterprise with its tail cone, which is pretty special. If you were to come to the Intrepid today, you'd see that tail cone. But if you went to see any of the other 3 orbiters that are still around, you would not see that tail cone because that is the last one in existence, which is pretty special, right? Now, what happened during this historic flight in 1977? Well, when it got up to about 26,000 feet, which actually isn't that high, they separated. And now the Enterprise is gliding through the sky just like a paper airplane glides through the sky, right? At this point, the space shuttle has no fuel. So it's using those wings to be aerodynamic and to bank and slow itself down to take away some of that speed so it can come in for that controlled landing on a runway, right? Just like you can see here, you can see space shuttle landing. This is the space shuttle Columbia landing on a desert bed. So you can see it lands like an airplane does with those back wheels first, and then those front wheels go down too, right? I see someone knew that was a shuttle. Someone said it was the shuttle with the bay doors open. Now, the interesting thing about the space shuttle is it only held about 8 astronauts. And the reason why is because most of this space was for cargo. There's a cargo space. So right where you see it says Columbia right there, all the way down to where it says NASA, that whole entire area is known as the payload bay, right? So that's where they're going to be carrying satellites, telescopes, and pieces of the International Space Station, all right? As I said before, we have the very first space shuttle here, or at the Intrepid. So whenever we're open, you guys can come and check it out. It's truly a sight to behold. If I'm not mistaken, it's actually, I think it's the only space shuttle that you can walk really closely underneath the belly. So it's like you get really close to history, which is pretty cool. Now, not only do we have this in the space shuttle pavilion on the top of the ship, we have something else, right? Now, this thing that looks like it has aluminum foil over it, it's actually the Soyuz capsule, right? And the Soyuz capsule is just another capsule that goes into outer space that's sent up by another country, right? Now, the Soyuz capsule has 3 main parts, right? You have the orbital module that does exactly what it sounds like. It's done to orbit around, right? It's to help it orbit. You have the re-entry module. This is the thing that comes back down to Earth, right? And brings the astronauts back safely. And then you have the service module. And the service module is pretty much where all the fancy equipment is to keep your heating and cooling and your energy all good, right? So that's where all the electrical stuff is, right? Now, this is what the inside of the Soyuz looks like. And I know a visitor asked earlier, they said the Mercury capsule looks very small, all right? So was it cramped? And you can see how cramped it was inside of the Soyuz capsule. Now, the Soyuz capsule had to be cramped for a specific reason. And that specific reason was exactly what you think, to land, right? This helped them land, right? Now, how do Soyuz capsules come back to Earth? Well, they slow themselves down. They re-enter Earth's atmosphere. They have a heat shield. They release that heat shield. And then the parachute comes out. The parachute slows them down. But this is a huge parachute. Look how big this parachute is, right? And you can see the main difference between this capsule and the other capsules we talked about. Because unlike those other capsules that land in the water, this one is going to land on the ground, right? And this is important because of where this thing takes off. The Soyuz capsule was sent up by the Russian Space Agency. Russia has a lot of landmass and not a lot of water really easily to get to, just like like Florida is, right? So what they did is they created something that could land on the ground. Now it uses this big parachute, but it also has these explosives at the bottom to explode outward, to actually push it up a little bit more, just to give it a little bit more time to catch a little bit more air in that parachute, slow itself down even more, and then it comes in for that landing. It's said that those astronauts during the space race, so the Mercury, the Gemini, and the Apollo missions, it was said that those astronauts, when they landed in the water, you usually saw them afterwards with sunglasses on, just enjoying the warmth of the Caribbean, right? But when you see these astronauts, you usually have them in these very special stretchers, because although they have those special seats inside, as we saw here, these special seats actually protect their bodies from when they land, so that way they don't break anything. It's still a bumpy landing because you're landing right on the ground, right? So that's the reason why you see the fire at the bottom of this picture here. That's supposed to happen, right? And once again, if you came to the Intrepid, you would see it encased here, right? Right underneath the tail of the space shuttle in the space shuttle pavilion, all right? So we talked about landing on the Earth, right? We talked about landing on the Earth specifically with capsules, landing in the water, and other things that land on the ground, like space shuttles and like the Soyuz capsule. But now it's time to talk about landing somewhere else, landing on another place, right? But before we do that, I just want to know, are there any questions at all about the Soyuz capsule, about the space shuttle? Any questions of anything that we talked about so far? And let's see what we have here in the comments here. No? Okay. Oh, so why did they stop using the space shuttle? That's a great question. So they stopped using the space shuttle specifically because we didn't really need to use it anymore, right? NASA was using the space shuttles to put those big things up into space. So when we built the International Space Station, space shuttle helped out with that. When we sent up the Hubble Space Telescope, space shuttle helped out with that. But after a while, we didn't really need to put up big things like that into space. And also, it was very, very expensive to send space shuttles up. And now NASA's minds are fixated on other points like the moon and another location that we're going to talk to about a little bit later. All right. Any other questions about the space shuttle or the Soyuz capsule? No? All right. So let's continue now and let's talk about that historic moon landing, right? So the moon landing, these three individuals, right? We have Neil Armstrong on the left. We have Buzz Aldrin on the right. And in the middle, we have Michael Collins, who is the unsung hero of the group, right? The other two are famous for walking on the moon, but he is very important because he is, as I like to say, was the getaway driver. He's the guy who was circling the block looking for parking. His job was to open the capsule for the other two astronauts when it was time to return home, right? But they went to the moon in something very, very interesting, right? They went up on a Saturn V rocket, right? And a capsule that was sent all the way to the moon. But in going to the moon, they had to think about a lot of different things, like the fact that the moon doesn't have that thick of an atmosphere, right? Very, very thin atmosphere, a lot thinner than Earth's atmosphere, which means, and it's smaller, which means that its gravity is a lot different, right? So landing on the moon would be a challenge, but they figured out a way to do it, right? And in order to do it, they use this, and this is just a kind of a model of it, but I like showing this because you can really see the three parts of this entire contraption here, as I like to call it. So this first part here is your service module, just like when we were talking about the Soyuz capsule. This is where your electrical heating and cooling and all that stuff is going to be. Right here, the number 2, that's the re-entry module. That's the one that's going to come back, and that's the capsule, right, that lands in the ocean. But what's really important is number 3, which pops up here. This is the Lunar Excursion Module, right, or the LM, the Lunar Module, right? And the Lunar Excursion Module was actually sent up by another Saturn V rocket shortly after the astronauts were sent up. And they rendezvoused or met up with this thing in space, and it docked with the capsule. And then it took them to the moon. Now, this is why this thing was important. Because as I said before, landing on the moon is a lot different than landing on the Earth. Another really big thing to focus on are craters, right? As a matter of fact, when they were landing where they were supposed to land on the moon, there were a bunch of rocks that actually inhibited them from landing. It stopped them from landing. So they actually had to overshoot it and almost used up all the fuel in their primary cells in order to do this maneuver, right? And then luckily, they landed safely on the moon, right? Now, this is the lunar module on the surface of the moon. A lot of people say that it looks like a face. It looks like has those eyes, and you kind of see the nose, right? But what stands out to me are those legs, right? The legs that make it look like a spider, right? And these legs are very, very important because, as I said before, because there's not a thick enough atmosphere, sometimes you can go bouncing, right? This is the reason why when we see astronauts on the surface of the moon, they jump up, they kind of slowly come back down, right? So if you were to land on the surface of the moon, you might bounce off, which wouldn't be too good for you or the caps or the thing that you were in, right? So the lunar module was made with these legs to absorb shock, which is really, really important, right? When landing on the moon. So they had to think about all of these things when they landed because they were landing on something solid, but it was a lot different than what they actually would land on the planet Earth, right? Are there any questions about the lunar module here? Any questions here? So Jamie Jackson asks, how cold is it inside? I'm not sure exactly how cold. I vaguely remember hearing something about the International Space Station being about like 70 degrees Fahrenheit, like a very comfortable temperature. I know that the capsules, the earlier capsules though, tended to be a little bit more hot, especially when you were kind of going through the hotter parts of the atmosphere. So it wasn't cold inside, but it wasn't unbearably hot. I know that they sweat a lot and things like that, and so they had to stay hydrated because it does get pretty hot inside of the capsule. Great question. Any other questions about the moon stuff? No? All right. So we will continue. Oh, Usher asks, is that gold? And if so, why did they use it? Yes. So they tend to use gold, especially on the plates of the coverings of the visors that the astronauts wear when they're up on the moon, specifically to protect them and shield them from solar radiation and the solar rays. Our atmosphere does a really good job of protecting us from that. But when you're in outer space, you're vulnerable to that. So using gold is a good way to protect your astronauts and your equipment up in outer space as well. All right. Great questions. These are really good questions. All right. So now we're going to move on to talk about Mars, because Mars is the object of NASA's obsession right now, right? We're constantly thinking about Mars, trying to figure out more things about Mars, trying to figure out if we can send people to Mars, right? Now, before we send people all the way to the planet Mars, though, we had to send rovers. We had to send different things that can do smaller jobs to let us figure out a lot more about Mars, right? So two of the rovers that went up to, two of the most famous ones that went up, we have this one, Spirit, and Opportunity. Now, you might be thinking, Franz, you put up the same picture, but I didn't. They're actually twin rovers. They look exactly alike, right? Spirit and Opportunity. Now, I have some questions that I'm going to be asking you guys a little bit in the chat, right? And we'll say Spirit is 1. So if you think the answer to these questions is Spirit, you're going to type the number 1 in the chat. If you think the answer is Opportunity, you're going to type the number 2 in the chat. All right. So once again, if you think the answer to these questions, and I'm going to ask you in a second, if you think the answer is Spirit, you're going to put the number 1. If you think the answer is Opportunity, you're going to put the number 2. All right. So we'll start off with this one. Which of the rovers went the farthest, right? Which rover went the farthest, right? On the surface of Mars, which one traveled the farthest? I will say this, one of them technically would have run a marathon on the planet Earth, all right? So write your answers, and remember, you're gonna write 1 if you think it's spirit, you're gonna write 2 if you think it's opportunity, right? Which one went the farthest? I'll see what you guys are writing in the chat. All right, so I see some 1s, I see some 2s. All right. I'm seeing more 2s than 1s, which is interesting. A couple more 1s have popped in. All right. So let's see what the answer is. Here we go. The answer is opportunity. Opportunity went farther than spirit. Right? Spirit, while opportunity went 26.219 miles, it's pretty far. Spirit only went 4.8 miles, which is a lot less, right? Now, the next question, we'll see what you guys say to this one. The next question we have, which one of these got some help from a dust devil? Which one of these got a little help from a dust devil? Was it spirit or was it opportunity? Remember, once again, if you think the answer is spirit, press 1. If you think the answer is opportunity, press 2, right? The dust devil, we'll see what a dust devil is in a second, but a dust devil is pretty much like a little dust tornado, right? Which one of these got some help from a dust devil? And I'll give you guys a couple more seconds to key in your answers, and we're going to see what the answer is now. The answer is spirit. Number 1, spirit got some help from a dust devil. And this is exactly what happened. One day, Spirit was out and about, kind of doing his mission, and there's some crazy storms, some crazy dust storms all over Mars. And there was a dust storm that knocked dust all over the solar panels for Spirit. And Spirit wasn't getting any power from the sun. So it almost shut down. And NASA thought that Spirit's mission was over. But luckily, the thing that stopped Spirit from working actually was the thing that pretty much helped it start working again. Right here is a dust devil on the surface of Mars. You can see right here, I'll circle it there. That's what a dust devil looks like. You can see that column of dust that's spinning. And one of those went across Spirit, knocked off all the dust from it, and allowed power to go back into the cells of the rover. All right, which is pretty interesting. All right, so the thing that kind of stopped it from working is the thing that saved it. Question 3, which one of these had a broken wheel that made a great discovery? Which one of these had a broken wheel? This broken wheel caused it to discover something that had never been discovered on Mars before. Once again, if you think the answer is spirit, you're going to press 1. If you think the answer is opportunity, you're going to press 2. All right. Once again, something that was unexpected that happened to Spirit ended up being something really good for NASA. So looking at the chat, I'm noticing there's some 1s. I see a lot of 1s. I see some emphatic 2s, which is awesome. All right, so let's see. And the answer is Spirit. Spirit had a broken wheel, and that's actually why it didn't travel that far. Because this broken wheel was just dragging across Mars's terrain. And as it was dragging across Mars's terrain, it kicked up some more dust, but underneath that dust was this white stuff, which NASA kind of analyzed and found out that it had compounds that are essential for life, right? So we've already discovered that Mars probably had water on it, right? And now we're finding different molecules, organic molecules in the soil that are necessary for human life. So this gave NASA a little bit more traction to the idea that maybe something could have lived on Mars's surface a long time ago, right? And this is discovered specifically because of an error that happened with the rover. And now the last question that I would like to ask you is, which one do you think had a longer mission length? Which one do you think had a longer life, right? Longer lifespan, right? Do you think it was Spirit? Once again, that's one. Or do you think it was Opportunity? Which one do you think had a longer lifespan? So I think I see some twos. Some twos are popping up in the chat. All right. Give you guys a couple more seconds to key in your answer. Which one of these had a longer mission length? And based off of some of the answers that we talked about before, you can probably guess that the answer is 2, Opportunity, right? Opportunity had a longer mission length than Spirit. While Spirit was around for about 6 years, which actually was longer than NASA had actually expected, Opportunity lasted for over 14 years, which is really, really exciting, right? Great job with that, guys. Thank you so much. Give yourself a round of applause and a pat on your back if you got some of those correct. Now, how did they land on the surface of Mars, right? Because Mars is a little bit different than the planet Earth. For instance, Mars also has a thin atmosphere, right? Mars also has lots of windstorms, as we talked about before, and lots of rocks and things all over the ground. So landing on Mars would be difficult. And we can't do the same thing that we did with the lunar module because we can't really connect that stuff that far in outer space. Mars is terribly far away, right? It takes about, I believe, 8 months to get to Mars. So they had to figure out something to absorb the shock when these things landed on Mars' surface, right? And what they decided was this. They decided to use these great things, right? If you look at the bottom right here, you notice these things that look like grapes, these yellow grapes, right? And you notice a parachute and some rockets, right? Now, interestingly enough, there's more of an atmosphere on Mars that you can use a parachute to slow you down, but it's still pretty thin. So you actually need some rockets to slow you down even more, just like we were talking about with the Soyuz capsule and those explosions that pushed it up, right? Now, once you get to a certain height, you can actually drop those great things and you can have them bounce, literally bouncing really, really high until they lose energy and come to a stop. Now, the material of these balloons are made out of something similar to what astronauts wear for their spacesuits. So it's pretty durable. And they made it that way specifically so that way rocks wouldn't rip it and cause it to pop. Now, once it gets to that stop, each one of these balloons deflate. And then you get this raisin looking thing, right? And inside of the raisin is this, right? Folded up, we have those rovers. Spirit and Opportunity both came to the surface of Mars using this technology, right? Now, there's still a rover up on Mars right now, right? And what I'm going to do is show you the Mars laboratory or Curiosity, and I'm going to show you how that one landed on the surface of Mars. Because whereas these could do this because they were smaller, Curiosity is going to be the size of an SUV. So you can't have it bouncing around, right? So, but we got to control the way it lands. So how are we going to do this? Well, I'm going to show you guys a video of how we do this, right? Now, before we begin, this software that you're going to see is a free software that anyone can use. And maybe we can put this software in the chat. This is called NASA Eyes, and you can use the free web version, or you can download a free version on your computer, and then you can look at some of these really cool graphics of things like Curiosity landing on Mars. So let's take a look at what it looks like when Curiosity lands here on Mars, right? So as you can see here, Curiosity is spinning around, and it just lost that top piece. The reason why it's going to lose that top piece is because now we got to have a parachute come out. As we get closer to to Mars's atmosphere, you're going to start noticing kind of a bow shock, which looks like force coming out of the front. And that's because it's traveling really fast through a medium or through air. As it's traveling through air, it's actually going to rub up against that air and cause friction, which is going to generate a lot of heat, right? You're also going to be generating this plasma around your capsule as it's coming, or excuse me, as around your let's pause this, around your rover as it's coming in. That's what you see right here. All of this white stuff, that's plasma all around it, right? Now, shortly after you enter Earth's atmosphere, now you're going to need to slow yourself down considerably. So you're going to deploy your parachute, and your parachute is going to come out at the top, and the parachute is going to come out and catch Martian air, right, and slow you down, as you're going to see here. Now, if you notice the Martian terrain, it does have craters and it does have rocks, right? But there that parachute goes now. And you might have noticed also, not the only thing that happened. At the bottom, the heat shield came off and it's exposing the rover that's underneath, right? So now you can kind of see what we're about to land. Now the parachute is no longer useful. So now we're going to dislodge it, right? We're going to have it jettison and go somewhere else on Mars, right? There it goes there. And now we have the rover. And what's cool about this rover is those retro rockets that we saw before on the parachute, now the rover has it on itself, right? But we're actually going to separate from this now and have these wires come down. And these wires are going to act just like shock absorbers, right? They're going to absorb the shock once this lands on the ground, and it's going to gently place it and then fly off away, right? Into and crash far away from the rover on the surface of Mars, right? And that's how we have to land a rover on Mars. So you can see it's a lot different than landing, say, a capsule in the ocean, right? Now, do you guys have any questions about how those things landed on Mars? Do you guys have any questions? Are both rovers currently on operation? No, unfortunately, both of those rovers are not, but Curiosity still is. And also Perseverance is going to be landing on Mars next month. And that's the new rover that's setting out to find out more stuff about Mars. And this one's going to tell us a lot more information, whereas the other ones were telling us a little bit about the composition. This one's also going to tell us a little bit, this one and the Curiosity are going to tell us about the biology, a little bit about the biology of the planet, if there's anything that potentially lived there or lives there, anything like that. So it's going to be pretty interesting. Any other questions? Is someone controlling the probes with a remote control, like a remote control car? In a way they are, but there is a lot of latency, and latency means there's a bit of lag. So I forgot how much the time is. I think it's a couple of minutes. But whenever you send kind of a command to those rovers, it takes about a couple of minutes for them to actually receive that command and do it. So you're actually working a little bit ahead of what the rover is doing because of the distance. It's a good question. How fast does a rover descend to the ground by Jamie Jackson? I'm not sure how fast it does, but I know it has to go down pretty slow because of the fact that you don't want those wheels to be damaged. If you look here, you might notice there's two different wires, right? There's wires that are tight or taut, right? They're really straight, but then there's wires that are a little bit loose, and that's also to help absorb the shock as it's coming to the ground. It's not coming down at a tremendous speed once these retro rockets come out, because it's actually trying to stabilize itself to land on Mars. Josh asks, what about waste? Does it just stay on Mars forever? Yes, unfortunately it does. There's no way for us to get it. As a matter of fact, there's no way for us to get these rovers after they, pretty much end their mission on Mars. So they just kind of just stay there. I'd imagine though, hopefully, if we send astronauts there, hopefully they'll pick them up and bring them back home, because those things would be awesome to put inside of a museum somewhere. Be something that was on Mars for a long period of time and we can bring it back. So, all All right, and also you guys can check out this program that we're talking about right here, NASA Eyes at Home, by visiting eyes.nasa.gov. And like I said before, you can simply just use the web-based browser or web-based program, or you can actually download it and use it on your computer. The downloadable one has a little bit more options. But both of them are really, really awesome. You can see this is a computer simulation. You can see other computer simulation of other probes or other things that went to different planets in outer space. And it makes it truly engaging and interactive, which I think is pretty cool. Are there any other questions? Any other questions about landing things? So we talked about lots of different things landing on lots of different places, right? And so, there's a question here. Go Tom asks, what about sandstorms? How can they predict it before landing? They can predict the sandstorms because just like Earth, Mars has weather patterns, and Mars has a year they call their sols, and they have these sols, and during the sols there's pretty much winter and Martian summer and Martian spring and all that stuff. And when those storms are the heaviest, scientists know based off of what time of year it is and what what hemisphere this thing is happening in. So great question. Great question. So, ladies and gentlemen, I'd like to thank you all so much for joining us for this virtual Intrepid adventure. Thank you so much for watching. You guys, please follow or subscribe to our channels, our YouTube channels, follow our Facebook page, or visit our website, which has our latest streaming schedules. The links are in the description below, so you guys can see where that is. We are doing lots of different free programming. So once again, if you guys are interested in helping us out and helping us create this free programming, please consider donating. You can see the link down in the chat. All right. But if there are no more questions, has it touched down? I think. Are you asking if, maybe you're asking if this thing touched down? Let's see. So here, I'll kind of rewind it a bit here so we can re-see it landing. Here, once the parachute comes out, the heat shield goes away. And then once it comes out with those retro rockets, you can see then it has these wires to kind of take away that shock as it lands on the Martian surface. So they're the retro rockets, excuse me. Slowing it down. And there it is, dropping that large car-sized rover on Mars. All right. So thank you all so much once again for joining us, and I hope you guys enjoy the rest of your day. And I hope you guys join us for our next program, by the way, which will be on Thursday, our Journey to Space program. We're going to be talking about a little bit about some of the stuff we talked about here, but also talking about specifics of space, being in space, living in space, and what it takes to get into outer space. View our schedule of our upcoming virtual family programs at intrepidmuseum.org/education. All right. And we will see you all very, very soon. Bye, everyone.